Hi friends, today we discuss about isomerism. First point is the concept of isomerism. First, isomerism observed in 1827. Justice Liebig prepared fulminic acid and Friedrich Fowler prepared cyanic acid. This is the structure of fulminic acid and cyanic acid. Silver fulminate studied by Liebig was explosive. Silver cyanide studied by Fowler was not. The compounds having the same molecular formula but different structural arrangement represent different compounds are called as isomers, and the phenomenon of that isomer is called as isomerism. Okay, then see the isomerism. In 1828, Friedrich discovered the urea that has the same atomic composition as the chemically distinct ammonium cyanide. This is the structure of urea, beginning of organic chemistry as the first in vitro synthesis of a chemical compound. Then there are different types of isomerism. See, first the isomers having different sequence of atoms, and the second same sequence of atom. Again, the isomers having the different sequence of atoms are divided into two parts. First one is the structural isomers and second one is the stereoisomers. First of structural isomer is chain isomer, functional group, position, ring chain, metamerism, and last one is the tautomerism. And stereoisomer is divided into two parts, conformational isomer and second is the configurational isomer. Again, configurational isomers are divided into two parts. First one is the geometrical isomer and second one is the optical isomers. Then see the structural isomerism. Structural isomers, that means constitutional isomers, are classified into different classes like chain isomerism, positional isomerism, functional group isomerism, chain ring isomerism, metamerism, and last one tautomerism. Then see the chain isomerism. The isomers with the same molecular formula but differ in length of carbon chain or straight or branch chain are called as a chain isomers. This is the structure of N-pentane having 5 carbons. Here only the same molecular formula but the differ in length of carbon chain. These are the examples of chain isomers. Then positional isomerism. The compounds with having the same molecular formula but differ in position of the functional group is called as a positional isomers. These are the examples of positional isomer: 1-chloropropane, 2-chloropropane, third is the 1-butane, and last is a 2-butane. Here only the molecular formula is same. Here the only position of the functional groups are different. So these are the examples of positional isomerism. Then see the functional group isomerism. Functional group isomerism having the same molecular formula but differ in the functional group are called as a functional group isomerism. See the examples of methyl acetate, propanoic acid, dimethyl ether, ethyl alcohol are the same molecular formula. Here methyl acetate and propanoic acid but differ in the functional group. And the same here in dimethyl ether and ethyl alcohol, molecular formula is same but differ in the functional group. This is called as a functional group isomerism. Then metamerism means the type of isomerism is due to unequal distribution of carbon atoms on either side of the functional group in the molecule. It's called as a metamerism. This diethyl ether and methyl propaxy ether is having the unequal distribution of carbon atoms on either side of the functional group in the molecule. This is called as a metamerism, and the molecules is called as a metamers of each other. Then ring chain isomerism means the compounds having the same molecular formula but differ in the linkage of carbon atoms. And the isomers either have open chain or closed chain. See here propane is open and cyclopropane ring is there having the same molecular formula but differ in the linkage of carbon atoms. This is called as a ring chain isomers. Then last is a tautomerism. Tautomerism means the isomers which are interconvertible and coexist with each other at equilibrium are called as a tautomers, and this phenomenon is called as a tautomerism. This is enol form and this is ketol form. This is called as a tautomerism, and one of these is called as the tautomers of each other. Then see the stereoisomerism. Isomers having the same molecular formula but differ arrangement of atoms or a group of atoms in the space are called as a stereoisomers. Stereoisomers are of two types, conformational isomerism and second is the configurational isomerism. Conformational isomerism means the stereoisomers which can be converted rapidly at a room temperature without any bond breaking. And those isomers are called as a conformers, and the phenomenon of that conformers is called as a conformational isomerism. The highly interconvertible isomers cannot be separated from each other. That means different arrangement of atoms that can be converted into one another by the rotation of carbon-carbon single bond. Then configurational isomerism means the stereoisomers which cannot be converted unless a covalent bond is broken is called as a configurational isomerism. Configurational isomerism is of two types, geometrical isomerism and second one is the optical isomerism. Then see here the projection formula for three-dimensional molecules. Organic compounds are having three-dimensional structure and it is not easy to write to depict on two-dimensional board or paper. To overcome this problem of writing the three-dimensional molecule in two-dimensional paper, following projections are used. There are different types of projection formula, wedge and dotted line formula. Second, Sawhorse projection formula. Third is the Newman projection formula. Last is the Fisher projection formula. This is wedge and dotted line formula. In this representation, one of the carbon bond is in the plane of paper and the other bonds to carbon atom are classified into three types. First, the bonds which lie in the plane of the paper are shown by normal line. The bonds projecting towards the observer are shown by thick bond. The bonds projecting away from the observer shown by dotted line. Then second, Sawhorse projection formula. The bond between the carbon atom is diagonally implying that it runs downwards through the plane of the paper and is slightly elongated. The substituent on each of the carbon are then projected on the plane of paper making an angle 120 of each other. This is the substituent. This can be represented as an eclipse or the staggered. This is the structure of eclipse and here staggered conformation is also there. Then Newman projection formula. The molecule is viewed along the carbon-carbon single bond axis keeping one carbon atom in front of us. See the first structure, the front carbon atom by a circle point and remaining three bonds drawn up to the center of the circle point making an angle 120 which each other. Okay, rear carbon atom is exactly behind the front carbon and represented by a circle and the remaining three bonds drawn up to edge of the circle. This is the structure of staggered conformation and eclipse conformation. Then see the Fisher projection formula. The molecule is oriented in such a way that the carbon chain becomes vertical. Horizontal bonds are towards the observer or above the plane, and while the vertical lines groups are away from the observer or below the plane. This is carbon, single bond carbon is there. Then this is the incorrect representation of Fisher projection formula. Today we stop here. Thank you.